Howdy, y'all. It's been a hot minute since my last vid, so thank you for being patient with me. Hopefully you guys all had a fantastic break. And we're going to jump into Chapter 5 now. Chapter 5 is about exponents and what we call exponential functions. So 5.1 is a little bit of a review from 8th grade. Chapter 4 was all about systems of linear equations, and 3 was about just linear equations. So now we're kind of moving on to a different kind of function or equation that is called exponential. Okay, so our Common Core State Standard is ASSE1, which says interpret expressions that represent a quantity in terms of its context. So basically just looking at different kinds of functions and saying what they represent. Okay, so first, this says to copy and complete the table, basically just reviewing what your exponent rules are. So remember, if you have 2 to the 4th right here, this really just means 2 multiplied to itself 4 times. So 2 times 2 times 2 times 2. And that's going to be 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So this is going to be 16 here. Okay, 2 to the 3rd is just 2 times itself 3 times. So 2 times 2 times 2, which gives us 8. This one is 2 times 2, which is 4. Now we just have 1, 2. So that just becomes 2. And then we get to these 0 and negative exponents. And if you don't remember the rule, because I know we've talked about the rule before, but you can just look at the pattern here. So what's happening when you go from 16 to 8, 8 to 4, 4 to 2? Well, you're just dividing by 2 each time. So we're going to do the same thing to get to 0, because really you can't really have 0 2s. That kind of doesn't make sense intuitively, so you just have to follow the pattern. So divide by 2, and we get 1 here. And then divide that one by 2, and we get 1/2. Divide that one by 2, and we get 1/4. That's a 4. Okay, so every time you go down, you're just dividing by whatever your base is. If our base is 10, that basically just means you have 1 with 4 zeros. Okay, so 10,000. 10 to the 3rd is 1 with 3 zeros, or 1,000. 2 zeros, 1 0, and then no zeros, so just 1. And then at this point we just start dividing. So 1 over 10, or 0.1, and then 1 over 100, or 0.01. So you're just dividing by 10, following that pattern. Okay, which brings us to our exponent rules of 0 and negative exponents. So if you remember, anything to a 0 power is always going to be 1. So 4 to the 0 is 1, negative 3 to the 0 is 1. As long as your negative is in parentheses like this, it's still 1. 5.14 to the 0 is still 1. Anything to the 0 is 1. Okay, so don't forget that. It's not 0, it's 1. Okay, and that's because of the division pattern that we did in the previous slide. Okay, and then if we have negative exponents, when you have a number a to the negative exponent, a to the negative n, remember it just becomes a fraction. Okay, so we just put that over 1, so 1 over a, and then your exponent becomes positive. Okay, so when you make it a fraction, that changes your exponent from negative to positive. This one right here, 7 to the negative 3, you just make it a fraction, and it's going to become 1 over 7 to the positive 3. Okay, next one is going to be 1 over negative 5 to the second power. Okay, and that negative 5 is in parentheses. Alright. This only works for non-zero numbers, so like this one, 3 to the 0 is 1, 2 to the 0 is 1, 1 to the 0 is 1. So if you look at this pattern, you would think 0 to the 0 is also 1. But then you have to consider this other pattern here. 0 to the 3rd is 0. 0 to the 2nd is 0, because 0 times 0 is 0. 0 to the 1st is 0, so that would imply that 0 to the 0 is 0. Well, 0 to the 0 can't be 1 and 0. That's why we say 0 to the 0 is undefined. Okay, so this rule right here works for any number that is not 0. Okay, so the only one it doesn't work for is 0. 0 to the 0 is not 1, it is undefined. Okay, next. Okay, so now we're just simplifying things. So 9 to the negative 2, when it says to simplify, remember that means to get rid of all your negative exponents. So this is going to be the same. We're going to make it a fraction. So it's going to be 1 over 9 to the positive 2. Okay, and then if you want to keep going, that becomes 9 squared, which is 9 times 9. 9 times 9 is 81. Okay, this one is a 0 exponent, so that should just be 1. Okay, negative 3.6. 0 is 1. It's not negative 1 because the negative is inside the parentheses. So it's just 1. Okay, some more examples here. I'm going to pause this and then you guys can try these and I will do them also. Okay, so pause this in 3, 2, 1, pause. Alright, so hopefully your answers look something like this. Okay, A should be 1 over 4 to the third, which just turns into 1 over 64. B is just 1 because it's a 0 exponent. C, 1 over 3 squared, which is 1 over 9. D, which is 1 over 6. And then E, you have that negative, so it's going to be 1 over negative 4 squared. But when you do a negative times a negative, this part right here, negative 4 squared is actually positive 16 because negative 4 times negative 4 is positive 16. So it just gives us 1 over 16. Alright, next. Okay, we've done things like this. Now we have multiple different bases here. We have a 5, we have an A, and a B. So when we do this, I always just like to start with a fraction line. Everything with a positive exponent is going to go on top. Everything with a negative exponent is going to move. Okay, so 5 we treat by itself, A we treat by itself, and B we treat by itself. So 5 has just no exponent, so it stays on top. The A is also a positive exponent, so it stays on top, so A to the third on top. Then the B, that's the negative, so that's the one that's going to move. So we're going to move that to the bottom, and it's going to become a positive 2. Okay, so we have 5A cubed over B squared. This one, the 1 is positive exponent, so it stays on top. But this x is on the bottom, and it has a negative exponent, so we're going to move it to the top to make it positive. So that becomes 1 over x, or 1x to the positive 5 on top. Then there's nothing left on the bottom, so we just put a 1 on the bottom. And this is really just the same as x to the 5th. Okay, so you're treating each factor, we call these factors because they're multiplied, each factor separately. So the 5, the A, and the B, we treat those all separately. Alright, next. Okay, go ahead and try these ones. You can pause this in 3, 2, 1, pause. Welcome back. Alright, so hopefully your answers look something like this. A and B, pretty simple, you're just moving them. So that's going to be 1 over x to the 9th, and then that one just moves to the top and becomes n to the positive 3. C, you've got, again, 3 different factors. So you have your 4, you have your C, and then you have your B. The 4 and the B don't have negative exponents, so they're going to stay on top of the fraction. The C is going to move to the bottom because it's negative. On D, the 2 is going to stay on top because it's not negative exponents, and then the A is going to move up to the top and become positive. On E, the m squared stays where it's at because it's not negative, but the 5 we're going to move down. And then because there's nothing left on top, we just put a 1. So it becomes 1 over m squared n to the 5th. Alright, we are cruising. Okay, this says, what is the value of 3s cubed t to the negative 2 when s is 2 and t is negative 3? This may also say evaluate. Okay, so when you see the word evaluate, that means that it wants, you're not just simplifying the expression, you're actually plugging in numbers and getting out a number at the end. Okay, so the first thing we're going to do is simplify this. Okay, so I'm going to make a fraction. My 3s cubed is going to stay on the top because they're all positive. My t is going to move to the bottom and become a positive 2. And now I'm going to plug in these guys. So 2 for s and negative 3 for t. So I sum my 3, and then my s becomes 2, and it is still cubed, over, and then my t is negative 3, and that is squared. Okay, and then when you're evaluating, you're just basically figuring out what your answer is. Okay, so 2 to the third is 8, so we get 3 times 8. Negative 3 squared is a positive 9. So then we multiply 3 times 8 is 24 over 9. And then simplify, always simplify your fraction. Those can both divide by 3, so that becomes 8 over 3. Okay, so that has now been evaluated. Okay, we came up with a number. So this part is simplified. This is when you evaluate. Okay, so two different words, important words there. Okay, so try a couple of these. You can simplify them first and then evaluate. Okay, but I will do these and we'll reconvene in a bit. Pause in 3, 2, 1. Pause. Alright, so I've done these. The black ink, fake ink, whatever this is my simplified, and then the orange is when I evaluated. So that's when I plugged in the numbers. On B, I didn't quite finish this because I ran out of room, but it should be 1 over negative 50 if you simplify the bottom there, evaluate the bottom. 1 over 5 to the 6th. I don't know what 5 to the 6th is. It's a big number though. Should be C, and then D is just 5 over negative 2 or negative 2.5. But if you look at E here, it says, is it easier to evaluate n to the 0, w to the 0 for n equals negative 2 and w equals 3 by simplifying first or by substituting first? And this one, well, they're both to the 0, so really this is just going to be 1, and this is going to be 1. So it's easier just to simplify it first because it's pointless to do negative 2 to the 0 times 3 to the 0 because you still end up with 1. So you really don't even need to substitute there. Alright, we are just about done. Clearly we have to do this word problem though. Alright, so this says a population of marine bacteria doubles every hour under controlled lab conditions. The number of bacteria is modeled by the expression 1000 times 2 to the h, where h is the number of hours and number of hours after a scientist measures the population size. Evaluate the expression for h equals 0 and h equals negative 3. So basically that's just saying plug 0 in for h and then plug negative 3 in for h. And what does the value of the expression represent in the situation? Okay, so we just plug these in. Alright, so we have 1000 times 2 to the h, that's our function. So first thing I'm going to do is plug in 0, because I want 0 and negative 3. So I get 1000 times 2 to the 0. 2 to the 0 is just 1, so 1000 times 1 is just 1000. So that's for 0. And then for negative 3, we get 1000 times 2 to the negative 3. And remember, 2 to the negative 3 is the same as 1 over 2 to the positive 3, which is just 1/8. So we get 1000 over 8. What's 1000 divided by 8? 500 divided by 4. 125. Okay, and then what does that represent in the situation? So, because this was h here. So, after 0 hours, there was 1,000 bacteria. That's what that's saying. Bacteria. So basically, you start with 1,000, and then after negative 3 hours, so that means 3 hours ago. Okay, if we're going backwards in time, so 3 hours ago there was 125 bacteria. So that means it's just growing every hour, and that's basically what it said. It doubles every hour. Okay, so 3 hours ago there's 125 bacteria. Right now, at time 0, there's 1,000. So, yeah. All right. Same thing here. This says it triples every week. It wants you to plug in negative 2, 0, and 1. Okay, so go ahead and do that. I will pause this. We can come back in 3, 2, 1, pause. Alright, so when you plug in negative 2 for W, you should get 600, because it becomes 3 to the negative 2, which is 1/9. And then 5400 divided by 9 is 600. So that means there's 600 insects 2 weeks ago. Right now, at time 0, there's 5400, because 3 to 0 is 1. And then next week, in 1 week, there will be 5,400 times 3, which is 16,200. That is way too many insects. Wow. Hopefully it gets full in the day. Just kidding. Anyway. Okay, so that's it. That's all for 5.1. Again, please do the quiz. Thanks for watching. Appreciate all of your hard work. Congratulations on making it halfway through the year. And yeah, I'll see you guys later. Adios.